Hello, and welcome to our presentation for Management 590, R for Analytics. I'm Drew Bertram, and over the past 6 weeks, we've had the privilege to work with our client, Harry's Fine Candies. Harry's Fine Candies was founded in 1932 by Harry Smith in West Lafayette, Indiana. Harry prided himself on offering a high-end menu that included just 3 types of candy: lollipops, gummies, and licorice. Today, the menu remains the same, and this commitment to quality and consistency has established Harry's as a premier spot for high-end candies and allowed them to grow to 25 locations across the United States. So you may be wondering, why does Harry's need our help? Well, recently, Harry's Fine Candies has received customer requests for high-end chocolate. As previously stated, they've only sold 3 items for the entirety of their store. But to meet customer demand, Harry's has decided to offer high-end chocolate options at their retail locations. But before they engage in this practice, Harry's wants to better understand the chocolate industry to ensure that the chocolate they're offering is truly the best in the world. As a result, Harry's has asked for our help in identifying the world's finest chocolate and the characteristics that make it so outstanding. After meeting with Harry's leaderships, we came up with 3 core questions that needed to be answered as a result of our analytics. They are: what part of the world sells the finest chocolates? Secondly, what is the geographical origin of the cocoa beans used in the world's finest chocolates? And lastly, what is the ingredient makeup of the world's finest chocolates? Before we get into our analysis, I want to introduce our team. Like I said, I am Drew Bertram. We also have Yuxuan and Kriti Sayal. Now, Kriti will walk you through the data we use to answer those 3 core questions.
Thanks, Drew. Now I'll talk more about data introduction and data summary. Harry's started off in West Lafayette, but since then they have grown a lot and grown multinationally. They have multinational clients and they are serving clients from all over the world. Therefore, what Harry's is actually interested in is looking at company location and country of bean origin of its competitors and how these 2 factors influence the ratings. Also, Harry's is interested in looking at the ingredient mix for the chocolates that are highly rated. Therefore, if you see at the table here, it has 11 columns, out of which rating is the outcome variable or the target variable. Now, the 2 columns, which are company location and country of bean origin, shows you the country location of the companies which are selling the chocolates, and also country of bean origin shows that where these companies are sourcing their beans from. Also, there are 7, 8 other columns which show you that what are the ingredients which go into the making of the finest chocolates in the world. Therefore, first starting off with the first column, which is count of ingredients, and then cocoa butter, vanilla, lecithin, salt, sugar, and sweetener without sugar. Now, with these factors, I'll take you into the world map to show you more about the company location and the country of bean origins, and that too on a world map. So here we have a world map, and now we can see the ratings by company location and country of bean origin. First, I'll talk about the company location and its ratings. And therefore, if you can see the light blue dots, these represent the countries which have the companies situated, which produce the highest quality chocolates. Also, coming to the country of bean origin, where these companies are actually sourcing their beans from. So if you can see this light blue dot, this is the highest rated country of bean origin, and it would be better for our client if they can also source the beans from this location. Moving ahead, we'll talk about the exploratory data analysis. So we did an in-depth exploratory data analysis in which we talked about 4 graphs, which is the histograms, the density plot, the box plot, and the scatter plot. In the histogram, we have a drop down which shows you histogram by different inputs. So here I would talk about count of ingredient. So in the count of ingredients, you can see that the chocolates have at most 6 ingredients, but most of the chocolates are made out of 2 to 4 ingredients. Then moving ahead on the cocoa percentage. So as you can see, most of our chocolates have a cocoa percentage of 60 to 80%. Also, the most interesting feature of this app is actually this box plot, because it gives the client an ability to tweak the inputs and see that what are the ingredients that are most liked by our clients. So here we go into the drop down of the x-axis of box plot and try to tweak it. So here, if we go on vanilla, then it shows you that the clients do not prefer vanilla in the chocolates. Also, if our client wants to know that whether whether the client likes sweetener in the chocolates, then we go on sweetener without sugar. And this plot shows you that the customers do not like artificial sweeteners in their chocolates. Summing all these three graphs together, we put up a scatter plot which shows you the rating versus the cocoa percentage, and it shows you that 60 to 80% of cocoa content and the rating of 2.8 to 4 is the most sparse data, and we would be interested into modeling this data and finding out the best input mix and the best ratings for our clients. From here, I would hand it over to Yuxuan to talk more about the summary statistics as well as the model optimization.
Thank you, Kriti. Next, I'm going to walk you through the last two parts of our application, that are the table summary tab and also the model optimization tab. As Kriti showed in the previous plot, if a user wants to see a specific number or a table summary of a specific input, we have provided those two tables for them to look at. Next, let's move on to the model optimization part. Since the client was trying to find out combination of content in a chocolate, which make it highly rated, providing a methodology to visualize alternative choices and set user-defined constraint to show rating outcome was essential to this study. And also, there's no optimal solution to the ingredient mix in a chocolate, as the client caters to customers with different taste preferences. So we have designed this model as a tool for user to design their own constraint based on their business need, and also calculate and maximize the rating based on their constraint defined by themselves. Next, I'm going to walk you through the model and see how can we use this model. As you can see from the side panel, we have designed this user-defined constraint functionalities, and this functionality allow user to choose their preferred company location, their preferred country of being origins, and also the user can choose whether to add constraint on cocoa percentage in the chocolate, the count of ingredient, the sugar, cocoa butter, lecithin, salt, sweetener, and vanilla. And also the comparable drop-down list and also the constraint value box allow user to choose whether they want to add their constraint to be greater than or equal to smaller or equal to a constraint value that will also be defined by themselves. And every time a user wants to finish this constraint setting, the user has to click add constraint first and then show the solution. And one feature of this model is that if the user doesn't change any of these boxes and want to use this as a default constraint setting, the model will simply give the maximized rating. And for a chocolate to reach this maximized rating as 4.6, the chocolate has to contain 42% of cocoa, and the number of ingredients has to be 6. And the company location will most likely to be Chile, and the country of being origin will most likely to be Samoa Island. And in addition, the chocolate will have no cocoa butter and lecithin. This is how we help Henry maximize rating and find optimized ingredient mix. Thank you for your time.